Hello everyone, this is Mr. McMillan and I'm here with an instructional video for the notes on circles in the coordinate plane. Now in previous math classes you've talked about various equations in the coordinate plane and what happens when you graph those. So for example, you were talking about linear equations, polynomial functions such as parabolas, cubic functions and all that stuff. But today what we're going to be talking about is specifically circles. Okay, so what is a circle? Well, a circle is defined as a shape consisting of all points that are equidistant from a fixed point. So they are equidistant from a fixed point. And all equidistant means is that they are the equal distance or same distance. So there's a fixed point where all of the points that are on the circle are the same distance away. Now, the fixed point of a circle is called the center. Okay, it's called the center of the circle. The distance from the center to a point on the circle is called the radius. It does not matter which point we choose. All points on the circle are the same distance from the center, okay? And that distance is always called the radius, okay? So the radius starts at the center and goes to any point that's on the circle. And regardless of what point you choose, the radius is always the same. Now, if we draw a segment from 2 points on the circle that passes through the center, this is called the diameter. The length of this segment, the length of the diameter, is twice the length of the radius. So the length of this segment is twice the length of the radius. So if we're writing this out in equation form, we would use D for diameter. So D is equal to, now the diameter is twice the length of the radius. So we would have 2 times our radius. And of course, our radius would be R. Your radius can also be said to be 1/2 the distance of the diameter. Okay, so D is equal to 2R. 2 times your radius gives you your diameter. Half of your diameter is your radius. So let's look at a diagram of a circle and label it with these parts. We'll also note some additional pieces we will need to determine solutions. So here we have a circle, and it's important to note that a circle only constitutes these points. The center is not technically on a part of the circle. It's just a property the circle has to help you graph the circle. So if we look here, this fixed point here, this is our center. Okay, that's our center. So the center of a circle is very important, but it's not necessarily graphed alongside the circle. Okay, we do a lot, and most of the problems we do have those things, but it's more of a visual aid than anything else. You will see some problems that do not have the center plotted whatsoever. All right. Now, if I draw this red line here, I'm going to draw this line starting here, going all the way over to here. Now, this is the, it goes from one end of the circle to the other end in a straight line, and it passes through the center. So that would be the diameter. So the red line here would be the diameter D. And then finally, the last part we're going to talk about in this video, we start from the center and go to a point on the circle. And that green line is our radius, which is R. Okay. Now, there are a few important properties of circles that we need to make sure we're aware of while we solve these problems. The first one, which is one we'll be covering in a future video that is related to it, and how to use it to solve for equations of circles and things like that, is the center point. The center is always the midpoint of the diameter. So the center is always the midpoint of the diameter. So remember, midpoint means that it is halfway along the line segment. Okay, it's in the middle of the line segment. It cuts that segment into two congruent parts. So for instance, here you have the diameter. At your center, you can see there's an equal amount of the diameter on this side as there is this side. Okay, and what we'll need in a future video, the midpoint formula, x1 plus x2 over 2, comma, y1 plus y2 over 2. Okay. The next property we're talking about is related to finding a radius. Now, in some cases, you will be given a center and given an endpoint, and it'll ask you to find the radius. Well, you can always use the distance formula to find the radius if we know the center and a point on the circle. Okay. So, for instance, if we're looking at the radius, your distance formula is the square root of x2 minus x1 squared plus y2 minus y1 squared. So just remember that's your distance formula. The third property is that the radius always begins at the center of the circle. So the radius always begins at the center of the circle. All right. So no matter how you draw your radius, it will always start from the center and go to a point. Okay. So no matter where, it'll always start at the center and go to a point. And then the last one, of course, which we've already talked about, the diameter is twice the length of the radius and vice versa. Okay, the radius is half the length of the diameter. So remember, I apologize for the lights. D is equal to 2 times R, which is your radius. Now, what if we wanted to determine an equation we can use for any circle? Well, if we look at this diagram here, our circle is always given as h comma k. That's the point we call the circle, the center of the circle. Okay. And if you look here, this x comma y, this ordered pair here, that is always a point on the circle. And it's important to note that the x and the y could be any value as long as that point is on the circle. So for instance, this here could be x comma y. This here could be x comma y, and so on and so forth. Now, if you'll notice here, we also have the radius. And when we draw a vertical line that extends downward to where the center is, and we draw a horizontal line from where the center is, we see that we form a right triangle here. Now, remember that a right triangle always has to satisfy the Pythagorean theorem. That is, a squared plus b squared must always equal c squared for it to be a right triangle. And remember, c is your hypotenuse. So a and b, you can label either of the legs as a and b. We're going to say that a is x minus h. We're going to say that b is y minus k. And c is equal to r. C is your hypotenuse, it's your longest side. So plugging those in, a is x minus h, so we get x minus h squared plus y minus k squared is equal to r squared. And that is your equation of a circle. Now it's important to note, h comma k is the center and r is the radius. Okay, so h comma k is your center and r is the radius. Now, I want you to look at the center here and look at your equation that we just found out. The equation has a negative in front of the h, but the center has a positive. That means that your equation and your center have opposite signs. This one's negative, this one's positive. You can see the same thing here with the k's. So the important thing here is that the equation and center always have opposite signs. So the equation and center always have opposite signs for h and k. So let's look at a problem. All right, let's look at some problems and see how we graph and determine the center and radius for our circles, using an equation or using the center and radius to write our equation. So it says for problems numbers 1 and 2, identify the center and radius of each circle given by the equation. So you'll notice here you have x plus 15 squared plus y minus 3 squared is equal to 121. Now remember, your equation is x minus h squared plus y minus k squared equals r squared. Now, if we're looking for the center, remember that it is h comma k. And remember, your equation always has opposite signs to your center point. You'll also note that the h is always with x and the k is always with y. So let's look here. We have x plus 15 squared. So we know that h will have to be 15. Now we just need to determine what the sign should be. So we see a positive here. Remember that the equation has opposite signs to the center point. So our x coordinate for the center is negative 15, not positive 15. The reason this works is because if we take x minus negative 15, when you subtract a negative, you end up with a positive, which would make that plus 15 next to the x. Then here we see that k is grouped with y, and we see a 3 here. The 3 has a negative sign. The equation and center have opposite signs, so that means that our k should be positive 3, and that's our center point, negative 15, 3. Now to find our radius, it's important to note this number here. We have 121. Now a very common mistake is that people just go, oh, that's our radius, and write that down. But that number is not the radius, it's the radius squared. So r squared is equal to 121. Now, if you have r squared equal to 121, you need to make sure that you can solve for r, because you're not looking for r squared, you're looking for r. Now, this has a squared on it, and if you remember, we talked about this a lot in the Pythagorean theorem, but the opposite of squaring a number is to square root it. But what you do to one side, you've got to do to the other. So r squared, or the square root of r squared, is just r. The square root of 121 is 11. So the radius for number 1 is 11. Number 2, we have x squared plus y plus 2 squared is equal to 64. We're going to go about it the exact same way, but you'll notice that this one's a little bit different. This time we don't have anything with the x. And what's important about that is that that can be rewritten as x minus 0 squared, because any number or anything that you subtract 0 from will always be itself. So if we want to find our center, h comma k, h is the number with x. So in this case, 0, since there's nothing there, 0 would be the number with x. So 0 is our k, or our h value, excuse me. Then if you look at the number that's grouped with y, you'll see that 2 is grouped with y. Remember, your equation has opposite signs to the center. So the equation has a positive sign, so your point should have a negative sign. Then to find your radius, r squared is 64. So in order to find your radius, you have to take the square root of both sides, and you get that r is equal to 8. So your radius there is 8. All right, so numbers 3 and 4, we want to identify the center and radius of each circle first, then sketch the graph. Okay, so I know with the virtual situation, if you find the center and radius and everything else, you should be able to identify a graph of it. So let's see how this would be done if we can graph this. So we have x minus 1 squared plus y plus 2 squared is equal to 9. What we're going to do here, we're going to find our center first. So our center is h comma k. H is grouped with the x and y is grouped, or k is grouped with the y. So we have a 1 here. Remember, your equation should have opposite signs to your center point. So the sign here is negative, so our center should be positive. And then we do the same thing here. We have a positive 2 in our equation, so our center should be negative 2. So we're going to go ahead and plot that. 1, negative 2. Then we are going to find our radius. Well, we know that r squared is equal to 9. So we need to square root both sides, and we get that r is equal to 3. Now, remember, your radius always starts from the center. So if it always starts from the center, you have to start here. And then we're going to graph a set of 4 points. So we're going to start here, and we're going to go right the radius. So right 3, 1, 2, 3. The radius always starts at the center, so we're going to go back to the center, and then we're going to go down 3 here. Then we're going to go from the center and go left 3, 1, 2, 3. And then we're going to go up 3 from the center. And then we're going to sketch the graph to the best of our ability. All right, now let's look at number 4. What would be your center on number 4? Well, if we look here, we see there is nothing with either the X or the Y. So that means there's zeros there. So our center is 0, 0. Then to find our radius, we know that r squared is 36. So we square root both sides and we get that r is equal to 6. So our center is at 0, 0. And then starting at 0, we need to go in the 4 directions, r equals 6 places. So we go right 6, down 6, left 6, and up 6. And then draw the circle to the best of our ability. Okay. All right, let's look at numbers 5 and 6. Numbers 5 and 6 say use the information provided to write the equation of each circle. So the center is -18, -3, and the radius is 7. So remember, your equation of a circle will always be x minus h squared plus y minus k squared is equal to r squared. Now, your center is always defined as h and k. So h in this case is -8. Well, if we do x minus -18, whenever you subtract a negative, the negative becomes a positive. So that becomes a positive. So your equation starts out here as x plus 18 squared. Then we do the same thing for the y. So we do y minus -3 squared, which ends up being y plus 3 squared. And then here we do r squared, which is 7 squared. And that will be 49. You can double check yourself. Does your equation have opposite signs to the center? Here we have a positive 18. The center has a -18, so those are opposite signs. Here we have a positive 3. The center point was a -3, so that's opposite signs. And then, of course, is 7 squared 49? Yes, it is. So let's look at number 6. Your equation, x minus h squared plus y minus k squared equals r squared. So in your first set of parentheses, you're going to have x, and then, of course, minus, and then your h. Well, in this case, h is 2, then squared plus. Now here you're going to have y minus k. Well, k is 0, and then equals r squared, so that's 17 squared. Now the x minus 2 squared, there's nothing to do with it, so we just write that down. If we do y minus 0 is the same as y, so this will be plus y squared, and then 17 squared is 289. So you look here, -2 is in your equation, +2 is your center, so that has opposite signs. And then, of course, since the center was 0, you can just have y squared there. And then the last two we're going to cover in this video, 7 and 8. We want to write the standard equation of each circle, and this time we are given a graph instead of just the points. But there are two things we need to know to write the equation of a circle. The first thing is the center. So what is the center in number 7? Well, the center, we can see here it's plotted for us, is 4 positive 2. Now to determine your radius from a graph, you start from the center and see how many units you need to go to get to the edge. And so if you look here, you end up having to go 1 unit, so your radius is equal to 1. Then, just like in numbers 5 and 6, you plug that in. So in your first parentheses, it's x minus h, so it's x minus 4 in this case, squared, plus then y minus k, which is 2, so y minus 2 squared, is equal to r squared. Well, r squared would be 1 squared, and 1 squared is just 1. So our equation here is x minus 4 squared plus y minus 2 squared is equal to 1. So see if you can do number 8, pause the video, and then come back and look at it. All right, so number 8, we need the center and we need the radius. Well, our center here we can see is -4, 3. And if we start from the center and go to the edge, we can see that we have to go 1, 2, 3 units. So our radius is 3. So writing our equation, we do x minus h. So we do x minus -4. Well, the equation has to have opposite signs. So x plus 4 squared plus, and then we do y minus 3 squared is equal to r squared, and r squared, your 3 squared is 9. So your equation for this circle is x plus 4 squared plus y minus 3 squared equal to 9. And that's going to do it for this video, guys. The other problems that we're going to be doing these tomorrow. These are a little bit more complicated and we ran out of class time, so we'll make sure to do these tomorrow. You are able to do the worksheet that's posted, and that worksheet is problems 1 through 18. You don't have to do numbers 19 and 20. I believe I wrote it in the instructions as well. I will have you do those at a later time. So thanks, guys, and I hope this video helped. I'm more than willing to stay after school with you as well. If you need that, just let me know, okay? So thanks, guys, and I will see you in the next video.